So I'll officially start. Welcome, everybody. Thanks for coming. So these are pretty informal. We typically ask somebody to do like a little 5 to 10 minutes about the paper to get going, and then I'll try to kind of lead us into some discussion points. But if people have stuff they want to talk about, we can go into that. I think with this paper, this obviously, as linked, this is, I guess we'll say out loud, this is the How to Fight Production Incidents, an empirical study at a large scale cloud service, aka Microsoft. Not really hiding that very much, particularly in Teams, which is pretty interesting. So if you look at the reading group that I linked that also went through this paper, they mention actually pretty some things that we'll probably get into, which is this is really, I don't know, specific to Microsoft. I mean, it is, but it's maybe specific to like super large company team projects. It might not make as much sense toward smaller groups, companies, products. Hey, Blaine. So that's, I mean, maybe we can get into with this paper is, the differences, I can use Blaine's, he showed up on here, who worked at Twitter in the early days, going to scale. When is scale important? How to fight fires? But what does it mean when you're not at the same scale, right? Do the topics and the correlations that come through in this paper actually do they make sense beyond the super large cloud code? I think it'd be really good to go through. I put some discussion points there. I took some from the other group. But okay, as we're getting going, who would like to start with like a little 5-minute presser about the paper? I'll give anybody who's not a fission person the first crack at this. But would anybody want to go through this, or who read it, or read at least part of it? Say anything? I think everyone's turning off their video and me is Brian.
Yeah.
Blaine?
I'll do
it.
Right. This is, I mean, as in the title, it's just an empirical study within Microsoft Teams to look at production incidents or failures. And they look at a lot of different factors that play into a production incident. And I think we can probably boil them down to issues around detection and monitoring, issues around determining the root cause of an incident, and issues around mitigation. And they look at this from a number of different dimensions. And there's also sort of the aspect of like what happens when a dependency fails, you have these sort of issues, but it's going on in a dependency, and what does that mean for mitigation? The study's over 152 production incidents, which to me seems like kind of a small sample size, but it seems like they're pretty rigorous with their methodology of like sort of tossing out outliers and trying to like find what results they can within there. And so they go through each of these different topics, and then towards the end they do an investigation of sort of multi-dimensional. They do a multi-dimensional incident analysis, which looks at the way that the different factors play into each other. And this is like sort of the big claim in the paper is that we have all these reports and we're able to look at these things not just in terms of this is what we should do better about monitoring, or this is what we should do better about testing code, but since we have all of these reports, we're able to look at them and see across them and make draw a couple of different conclusions. I think that's probably a good summary.
Yeah, thank you, Brian. I think that's really good. I mean, and tell me if I'm wrong for anybody who did read this or who skimmed it. There's nothing in this paper that I would imagine, and I could be wrong, that makes anyone go, whoa, no way. Right.
Yeah.
Actually, I think when I was reading this, I ended up just remembering bad times in my life. So actually, maybe it was just like that second, because it goes through like everything. Yeah, I had a couple notes that I wanted to call out as I shared here in my like the text workspace. Things. I mean, nothing that was too like out of this world, right? But like things like while software bugs are common root cause, a big portion, roughly half of the incidents are caused due to non-code related issues. I having worked for many years, this is a pretty common thing. They have a good actually the paper, I think one thing it does very well, though I think we'll get into like criticisms, right? I feel like it kind of goes nowhere by the end, but I do think that it has a really good set of findings. I really like how they basically go through like each of these things, each of these pieces with their percentages, and obviously the cross correlation they're able to do it toward the end is actually really cool. Actually, I think it's a really good summarization of some of the work when they actually are looking at mitigation and detection in that way. So for people here who again skimmed it or even just generally thinking about it, were there any as you think about bugs and mitigation detection, what things come up? And one thing that I think is really interesting, and again this is pretty recent for teams, obviously they talk a lot about infrastructure issues, and a lot of the infrastructure I feel like is correlated probably with the increase of Kubernetes, the complexity of Kubernetes. And so things like detection probably becomes more difficult. Any open things to kind of the beginnings, like taking on this kind of thing. I mean, there are other papers in this field as well. I don't know if people have come across those. They pretty much call out specifically their work on more high severity. They obviously could focus on one large company. They're not, a big issue you'll see, this is more coming from the academic side of things, is that they'll, a lot of papers in this space will do like open source projects, but open source projects don't really tell you the tale of like what's happening, in terms of a large company rollout and the ability to have things like autonomous measurement and triggers and all this other stuff that kind of go into things, and how important a piece like telemetry plays into all this. But yeah, their big call outs are they don't only analyze root causes, but they really look at detection and mitigation. They obviously did a lot of perusal on a bunch of work by on-call OCEs, right? They use your on-call engineers, and retrospectives and all the stuff that people have written over time. And of course, they bring up this multidimensional analysis to correlate the different stages. So yeah, anybody want to kind of who've maybe read papers in this kind of work or other research in this want to say anything or any other thoughts as we get to the as we talk about the early part of this paper?
One thing that I didn't notice, maybe I didn't really read it carefully enough, but there's having lived through a lot of these, it seems like there's often, or from time to time, there's a lack of alignment between the organizational structure and the structure of the app, of the software. And so you often end up with like really important, data that's really important to one group is like sitting over in somebody else's control plane. And they don't really care about it because it's like, var log, whatever. And so they have to, in order to get to it, they have to like work up the stack and then down. And so that's like the organizational structure. And then like procedurally, does the organization have this notion of exception management? In other words, if a problem comes up that is so severe that it's like out of the ordinary, do we in fact handle it like an out of the ordinary problem? Or do we simply handle it like an ordinary problem and just get more people in trouble? Like in other words, like when you're speaking to somebody who doesn't understand your language, you think that if you speak more loudly, they'll be able to understand you. It's like that kind of misalignment.
Yeah, I think that's a great point. I mean, I think this hits a lot on toward the end when they kind of talk about, again, and where the other reading group kind of takes a criticism on this paper is that it doesn't do enough to kind of talk about like what can we do to make things better. But one of the things that I think that they do get into toward the end is like how important technical documentation is, and how a lot of the on-call engineers felt that was really important. That's a big parlay when you're working with like external teams, right? That's like a huge piece of it, and that was a big percentage of a lot of things that we're missing. It's not just about obviously they get into the whole thing about testing and validation, and we know that like configuration changes are like the worst thing. But when you're working with cross teams and cross, they talk a lot of external properties or external teams, those API docs, the technical documentation, that's really the big way. And of course, that was one of the major issues that they talk about in this paper. So I do feel like, how do you best do organizational crosstalk, right? I think just to talk about personal experiences, and to me, that's what this paper does bring about for me. I think as you mentioned,
I mean,
as well.
No, sorry. Just to put a finer point on it, they talk about the root causes, but they characterize the root causes in terms of mechanical scenarios or idiosyncrasies of the infrastructure. What I didn't notice in terms of the root causes were, like, for example, people like to complain about docs. Like, okay, well, is it because the docs were incorrect, or was it because they were incomplete?
Right.
And
right,
if
right.
and if there was a problem with the docs, is it that you could only resort to the docs and then you had to escalate? Or could you escalate, if you will, through the docs, right? In other words, it would have been interesting to have a more nuanced taxonomy or characterization of the workflow.
Blaine, maybe you want to speak to that or speak to something like that.
Yeah, I think one of the, I only skimmed the paper, but because they're just focused on one organization, like the conclusions for different organizations are going to be completely different. And actually just like sitting here listening, I mean, obviously just the mention of root cause kind of raises some alarm bells because I come from the Allspa school. But thinking about, like, they've got they say most of the resolution is just roll back, right? If you have an on-call engineer who didn't write the code, then yeah, that's going to be the solution, because they're not going to know what the fix is. Right. They're just going to make the system run again. Whereas if you're, a 20-person startup and the on-call engineer is the person that wrote the code in the first place, then probably it's going to be a code fix, because like, oh, I messed that up, fix, done. And then you don't have to go back and do it later. So I think there's maybe an interesting framework for analyzing where failures in your organization come from, and maybe that's more of an interesting kind of takeaway, like the cross analysis that you mentioned. Like what's the methodology that you could use to apply that to your own organization to figure out where failures happen in your systems, rather than saying like this is true across the industry, because they're clearly not achieving that level of analysis here.
Yeah, it's a great point. And I think to your point, like, I think they present a very good taxonomy that anyone can take to bring to their company. I think it has more information, but to the point made earlier, it's not as nuanced, right? And I think that goes into things too. I mean, this data is built on things like retrospectives, and I've read a bunch, and there are some great ones actually, right? There are great retrospectives. There are a lot of retrospectives that are like, we were, this went down at this time, configuration change, and it's kind of just like reading these like details of like what happened, and that's how they measure, that's how they essentially measure their time. We detected the incident, now we do mitigation. They have all that because they actually for them, tracking that time is the most important thing, because that's obviously how they get into like, when do we have the next bug and how do we decrease that time? But what you don't get is the story, right? You don't always get the story. The great retrospectives have the story as well, but that means they're more work. I mean, there's retrospectives that, you know, read like great blog posts, right? And then there's other ones that are like, yeah, really, it's just about internal, you know, time, time between detection and mitigation. But I think it's a great point. Like, how do you take this to other organizations or your organization? Right? Anyone else with some extensions to that?
I mean, I work for Amazon, but Amazon, we have this culture of writing COEs. We write a story about 5 Eyes. Yeah, we write a detailed analysis. The intent is that you should understand why it happened in the first place and how you can prevent forever in the future. And if it's an important COE, that will be shared across the company as well. Like there is a company-wide ops meeting where that is shared, so that people can learn from other mistakes, and that way you can improve the process or mechanisms at a company level. Okay, you should be careful while doing configuration changes or certificates or something like that. So something that the entire organization company can learn.
Yeah, in company-wide op meetings, I mean, that's obviously a thing that I think has become more typical of the large cloud providers. It was even something we had when I was at Comcast. And those are actually really good, because it's really amazing to get a sense of like what other people are dealing with on other teams, right, across projects. I think it's even something that should be done on a smaller scale, right? It's kind of interesting to think about it. Like, we think about it only at the large cloud scale, large company scale, but these things are really important, especially for companies who are in that stage, you know, where they're like growing immensely and growing very quickly, because these things will come to pass very swiftly. Anyone else? It's a great point, Sharon. Thank you for that. Yeah. And it's good for companies to do this, right? Like, yeah, and sharing that information is key. To your point earlier, Blaze, is that, yeah, I don't know. You know, one thing is they talk about some of their sources, or yeah, obviously we know it comes from Microsoft Teams. How they kind of go, you know, we see how they do the measurements generally, but what is the data would be really great to see, like if they kind of open that up in some sort of anonymized way or something like that, right? Anyone else with some extensions to that thought, or anything else in this kind of beginning part of this paper? Configuration is bad. Oh, go for it, Rob. Yep.
Rob, sorry. I'm currently over at the archive. That's my context here, but with the GitLab thing yesterday or a couple of days ago where GitLab was down, I got reminded of some of the content that we had archived where they had like not even redacted the engineers' names and stuff. Full disclosure, I haven't read this paper yet. I just saw this and I'm like, oh, I want to at least sit in and say hi, but and like read the next one. But for what it's worth, GitLab did a pretty good job a while ago. I haven't seen their one for this time, but it's interesting to see all of the different approaches that people take to like getting this information out when this shit happens.
Yeah, GitLab actually always writes really good stuff. You know, I've always been a big fan. So if somebody has that handy, if they've written some up recently, that would be really good. You know, Datadog had a major one as well. I think they were down for like 13 hours. That's a pretty interesting retrospective as well. Yeah, those are actually some really good ones. GitHub has actually done some pretty good ones in the past as well. Yeah, I think to that point, like, you know, and for me, when I see this paper, you know, and you know, again, I can't speak specifically for Microsoft Teams or other companies, but what I do appreciate is some of the views toward measuring all this stuff and thinking about this stuff. You know, one of the worst things that I remember, and this is going back 2015 or something at Comcast, for when we did have a major thing with like Xfinity boxes going down, you know, going down to people's houses or stuff, and they can't watch the World Cup or something like this. You know, we would have these crazy triages where it'd be like a bunch of teams getting together on a call, but nobody knows what's happening. And I just imagine just the minutes going by where no one knows what, like just wasting time. And so, triage, like with all the wrong people on it, everyone's like, I think I know the fix. It's like, whoa, it's not even related to this at all. So anyway, I think seeing something so concrete makes me feel happy that maybe people are thinking in this direction. Maybe that's the positive takeaway. Yeah, so anyone else kind of any other kind of thoughts here on kind of how they build things up in terms of like the breakdown of the text failure? Anything you feel like they're missing in some of these pieces as well, before we get into kind of how they do their conclusions and stuff like that? Do you feel like there's something that's not tackled by these taxonomies in this paper? And for anyone kind of skimming it, or these findings, right? They talked about these findings. Does anything really like come out or call out to you as well? Please, people with hands, Blaze first.
The two things that immediately come to mind, I mean, to some extent, well, psychological safety, correlating these problems to things like psychological safety. I mean, I bring it up just because like the Accelerate book and the Dora people have done a lot of research in that. So it's sort of like, I'd be surprised that anybody doing research in this area would not somehow be influenced by some of those methodologies. And then the other one is outcomes. Like, is there, okay, what's the, is there any impact on like subsequent outcomes or results? Like, did any of this help?
Yeah, I think I linked earlier or in the Discord, and maybe Brian or someone can link it here in the Zoom chat. I think Teams had a big outage in January. That's like after this paper, because obviously the way it's written, academic, published, it might have been published 2023. I think it's 2022 anyway. But yeah, so that happened after this. So maybe, I don't know if that's the outcome, but major things happen. Yeah, Brian.
I'll link that in a moment after but I wanted to I was curious about digging into finding number 11, which is on page 137. So they say that 70% of incidents with no monitors were root caused by code bugs. It's inherently difficult to monitor regressions introduced due to code changes. For code changes, we should improve testing. I wonder if, like, I wonder if folks could speak more to this or give their experiences, because to me it seems like I understand that they're inherently difficult, or updating monitoring is inherently difficult, but is that a communication issue? Is this a big org type of an issue? I understand, sure, we all want our code to be tested better, but we also want monitoring to like do its job.
Yeah, I mean, I feel like, yeah, like this is all straight out of Allspaw's literal book, is it books now, I'm sure. Like Etsy famously didn't do any testing at all. Like they were anti-testing, and they were just like, we're just going to monitor everything, and if you do a code change and something breaks, then we'll know when it happened and we'll go and correlate that to the deploy.
And this is akin to like, even though it's used for sales a little bit, like Honeycomb's whole thing, right? Like, test in production by monitoring, right? And traces and stuff like that. I mean, it's kind of Charity's kind of thing that she sells off, right?
Yeah. And it makes sense because it's sort of, if you're just relying on testing a bug that doesn't show up right away, doing the analysis to try and find what happened is much harder. Like the things that they're talking, the incidents that they're talking about are like, oh, we deployed some code and then there was an incident right away that we were able to like figure out what happened. Yeah, no, for sure. Yeah, I think that speaks again to the sort of organizational structure, which is one of the things that I find an interesting omission that I was going to raise in this, is that like none of the root causes are our management sucks, our team organization is pants, like, you know, like that. And I think Blaise, you were kind of pointing at that, like, you know, I've definitely had situations where, you know, you come into work every morning and you're like, so do we have those 45 extra servers that we needed a month ago? And the answer is like, no, clearly we should just rewrite all of this in a different language and it'll be better. And that's like, you know, well, I can tell you where the incidents are at, like why the incidents are happening. And it's like, yes, it's kind of everything, but it's none of the technical factors actually matter.
Yeah, I think it's hidden in here. I think it's hidden in you know, deployment practices and all. I think it's hidden in there, right?
Mm-hmm.
And you can gloss over it because they can do things in sectors, and teams are very measured at Microsoft, for example. So it's hidden in there. But yeah, you're right. It's you know, the thing that it is lacking is, yeah, like that team that has probably a bunch of configuration outages because maybe half of it's like, I hate my manager, right? I don't care. I just want to get it done, right? Like whatever. That could be a part of it, right? So I think that's a great hidden. I think it's in the numbers a little bit, but it's obviously hidden. And obviously an issue with papers that are written by companies in this way. You can get a lot of great data. The alternative is you can't, there's a bias that's kind of built in, right?
Yeah, for sure. Like it's almost in the same way that the organization kind of resists that calling out. The paper is resisting the calling out because they exist within an organization. I did a quick word search and organizational doesn't appear in the document, and management only appears in relation to configuration management, which is just an interesting data point.
So you got to back it up with numbers. You know, academically speaking, I guess there is a problem. Like, you know, Sharon, please.
So sometimes even if you test your code 100%, you have 100% test coverage, all the integration tests, all the canaries, you can still get outages if your design is not sufficient.
Yeah, I wanted to go back to something that Brian brought up with monitoring too. But yeah, to that point, I mean, you know, I've been a big fan of property-based testing for years, and John Hughes and Quick Check and all these things. And John, they always talk about even with property-based testing, it's in the original paper with, you know, Conquest, and you know, it's up to you to write the properties. And if you can have all this great kind of apparatus for generating data and doing shrinking and model checking. If your model is not correct to your implementation, or if your properties are wrong, you know, you're not testing the thing that you need to test, right? You're missing out. To another point you brought up, Brian, I thought that was good about monitoring and the issues with monitoring, right? I mean, at the few places I worked on that were much larger or got larger, like at my last place, like a big issue is, you know, sometimes there is all the other side of monitoring where there's too much of it that makes no sense, right? Every at least I remember, you know, at certain companies, like every app wanted to like put every log everywhere, and the logs had no meaning anymore. So then when it came time to like, hey, there's an incident, there's an issue, let's go through the logs. It's like they're endless, right? You know, of course you can put head sampling, you can do all this kind of stuff to limit the number of logs, and that kind of thing. The back pressure effect on that had been issues at places too. But a lot of it is that people don't craft their monitoring story. We also know, you know, there's also a long history of things like people not caring about certain triggers or alerts because they're getting over alerted for things that are not important, because obviously determining severity is a major. I mean, it's kind of like the thing, if you don't test the right properties, or you don't have the right design, you're going to miss out on stuff. And the same thing with monitoring. If you don't design what you're monitoring for, you'll just end up with like, oh, I just get a bunch of alerts, but don't worry, they don't matter, they don't mean anything. We're just like, we have bad thresholds, right? So like, what is the auditing for that kind of stuff? So, you know, in the previous place I worked at, that was like a major thing. Like, how do we audit? Like, we should audit what we're doing, how we're monitoring, what data people were sending, right? It's not just about, that's the difference when I've written about like observability in the past. Telemetry is about the data that you're gathering. Observability is actually the hard work of and also the UIs and everything that come into play with like, how do I interact with trace information and instrumentation? How do I find answers, right? And even though I think GPT OpenAI is being used a lot now, every company now has their version of that. Like Datadog released theirs. Gene Yang's company Akita has one. I don't know if that solved that problem either, right? Because understanding what's going wrong is like the hardest problem, right? So you can have all the monitors that mean nothing, or mean nothing to the people who are working there if they don't understand.
It kind of reminds me of a story about 3 Mile Island and the near meltdown they had there. Back in that day, it was sort of early in industrial design and sort of UX design, and the panels were just like scattershot, just like the secondary coolant system was next to a control for the elevator, and like a super important gauge was like on the back of a panel or on the back of a control thing behind a panel, and just everybody started panicking and somebody misread one of the gauges and they took the wrong action. And so really that incident caused that whole industry to sort of figure out, how can we lay things out clearly? How can we surface the important stuff? How can we separate the signal from the noise? It seems like all this data, we want to keep it around, but I think that's what you're getting at with observability, that we want to have the important stuff float to the surface and be easily accessible, right?
Yeah. Signal over noise is exactly that, right? Accessible, and then it's the little things too. I mean, how many bugs are then themselves? You have bugs in your code, but you might have bugs in your telemetry, and in your observability practices you lay down. Like I think there was a major issue, forget which company, where they didn't figure out a real issue for a while, so it took longer to detect due to having the wrong unit in their graph, right? So that kind of small little thing can cause a lot of issues. Anyone else toward this? Other people have kind of in this vein of monitoring and other kinds of things like this. Cool. So I think people really want to talk. Oh, go for it, Brian. Go.
Well, one other thing about so on page 138, right towards the first paragraph there, they talk about misconfigurations and whether sort of traditional software testing can be used. And when I read that, I was like, is property-based testing possible here? Do we know if anyone's attempted anything like that?
Yeah, I don't know if anyone else wants to speak on this. So there is a lot of work actually. Configuration verification and configuration checking is really academically hot right now, particularly in networking configuration. Obviously servers and stuff too, but the big thing with networking configuration in particular is that you're basically sharing these, or fanning out these configurations to routers, switches, all across, right? And obviously how long it takes to kind of update those things, truly eventually consistent versus having some means to kind of lock things. And so network configuration has been one of the big fat fingering issues that people have had over years, right? And that's a little bit talking from an ISP, but if you look at the papers coming out of NSDI, a little bit OSDI, but NSDI and some of the networking, there's always 2 to 3 papers about configuration verification. But they're looking at it not just we're property-based testing, which is one means, but it's kind of a hammer. What people are kind of looking at are things of it's more like a constraints-based problem. So how do you define constraints, and then are you able to verify that this configuration is actually valid based on constraints that you might have through metadata, your network, right? Stuff like that. So there's a whole group of work, and various means at it. Some's taking like a programming language approach, some's taking more like a static analysis approach, some sort of combination approach. There's a lot of actually work in this sector. Configuration is, it's even an issue that I see, and I don't know if anyone's worked in, like a friend of mine at Datadog was talking about, even for like Kubernetes configuration, stuff like that. Like there's obviously there's ways to generate your Helm charts, and there's ways to do all this generation. But what happens, and maybe not really pictured here, like I think Blaine talked about the refactoring thing that people want to do, but there is like what people have told me in other places, like, oh, we use this generator for this, but people don't like that generator, so they write a thing that generates to the generator template to generate the thing, and then you start actually getting things that start syncing away from each other, right? And so there is a lot of that occurs as well, even in infrastructure land. That's another big, obviously, the other big configuration thing that there's problems. Configuration, it's like probably the most boring thing, and yet to this this paper shows, in terms of its, most people just roll back, but it is essentially, in my time, it's DNS. DNS is a bug in D or DNS configuration. Like configuration is probably like the thing that feature flags versus configuration. That's a big thing. It's talked about here in this paper. These are the worst things, right? That cause a lot of problems.
Well, that kind of this is maybe, I don't know if there's other stuff that we want to talk about, so this can just be a pin. But one of the things that kind of is in my mind in relation to this paper is like a lot of the stuff that we're doing is totally decentralized, like actually distributed, decentralized, not like managed by a single organization. And so like, a lot of the IPFS failures you could claim are probably configuration failures more than like software failures per se. So it's sort of, I guess the question is like, how does incident response work? How would we take this sort of discussion and apply that lens to a fully decentralized sort of system or a federated system or something, where we still want everything to work, but we don't have this sort of like cohesive response mechanism, I guess. I don't know. But
in some ways,
again,
it's harder actually, right?
Yeah.
But yeah, I would love to get people's thoughts on that. Like, as you move toward a semi-decentralized or more fully decentralized system, how do these things come into play? It's a great question.
I used to joke about the 4 enduring mysteries. You know how in SRE they have like the 4 golden signals. Yes. So
For sure.
So I came up with the 4 enduring mysteries, which are like the 4 questions that nobody really wants to answer, but everybody always wants to ask. The first one is, how can I tell if it's working? These are things that should really be like considered at the design level, right? But they get skipped because they're gnarly. And the second one is, what should happen if something goes wrong? And the third one is, how can I tell if anyone's using this? And the last one, this is the one that got me kicked out of engineering meetings. How much better is this release than the previous one?
That's a really good one. Yeah, that last one's a really great one, right? Like, that gets into a whole world of, depending on what you're building. Of course, if it's more product oriented, if its performance is the key thing for it, like you talk about the feature, like, are you measuring regressions to like performance benchmarks, this kind of stuff, right?
Yeah.
These are or you've added a bunch of features and it's made it where it's unusable, right? I mean, that's a great example of that failing, right? That last tenant failing. So those are all really good. Anyone else to that? So I think I have some thoughts on the decentralized one, which is the issue is you can share a lot of data. You can nodes, peers, if you think from a peer-to-peer standpoint, can share all this metric information with each other. You can obviously still centralize your metrics for what you're running. But the problem is you ended up, if you're running hundreds of thousands of nodes, you're which is like a different than like even like a multi-region thing where you might be running, let's say, even hundreds for a certain service. And then you're also dealing with the fact that anybody, a decentralized kind of perspective, and tell me if I'm wrong, Blaine, if where you're going with this, but the ability for people to run their own version of something, right? Their own version of your code, and they're also participating in that decentralized network. How do you know they're giving you the right data, right? Or, and this kind of stuff that comes into play, let alone like Byzantine problems that might be there, right? To questions of like, am I getting the right thing? Am I seeing the right thing? Or nodes, are people actually seeing the data coming from nodes that are spinned up? Yeah, I think there's a centralization stuff that you have to obviously have, but then the question is, how do you limit the amount of data or only share the most important data? Is a big part of that as well. Who's paying for all that data? But yeah, anyone else to that answer? How does this stuff work for decentralized platforms?
Like in the case of Mastodon, which seems to be coming up a lot lately, I got into a little bit of a discussion. I think I rubbed Evan the wrong way, which is, I didn't mean to. I mean, I love the guy. But anyway, I made a comment to someone who's been interested in this whole DID, in other words, the identifier thing. And basically, what I pointed out was that all of the conversations around distributed privilege, they're really more about authentication, not authorization. And that everyone punts on authorization. And, arguably that might be the reflection of the fact that we don't really have a proper directory service among the suite of internet resources that are common, sort of ubiquitous. And directory services seem to have like fallen into disregard. And so like the whole notion of like, how do you keep the access controls and bind them to a particular user or a group of identities? That's like subject to the
I
server's
think we just
discretion.
queued up Blaine to talk about some work he's been working on. I mean, so access directories are kind of the anti-centralization, but
yeah, no, in his defense, I did pick up on, so I think Evan was saying that they do, basically what I noticed was one could argue that the current way that ActivityPub has of dealing with that is they basically refer you back to your server of origin. So if you're out there cruising around and you see a piece of data and then you want to like reshare it or boost it, you're basically redirected back to your home, to the context of your home server. And then that determines, which is actually not terrible. I mean, but I think it should be at least articulated as like, oh, that's our strategy, right? Instead of saying, oh, we've solved all the problems, which is not true. It could be, well, we haven't really solved all the problems, but this is the workaround that we're using right now. And I think that would be okay. I think if there was more transparency, and he was cool with that. He agreed that he was going to like, rewrite that section of the ActivityPub intro primer.
I can actually, this is actually very relevant, I think, to the paper. So I can speak directly to that, the Webfinger stuff, which is not strictly ActivityPub, but like that's how it's done. Was something that I created for what year are we? 15 years ago. And like at that time, that was explicitly understood that that's what we were doing, right? Like it was really, really intentional and clear. And then you put 15 years of obfuscation along the way, and people are coming back and they're like, oh, here's this technology. There's no like, there are probably hundreds of pages of documentation, but none of them like addressed. And in a lot of cases for political reasons at the W3C level, right? Because they didn't want the WebFinger stuff to be part of it because it's all just HTTP URLs, right? Right. And so it's kind of this like, there's a whole bunch of organizational, but like decentralized organizational obfuscation that has gone in, and a lot of those like things that people have been doing it for a very long time understand implicitly aren't stated in public, and like there's not a consensus around. So I think that's, I mean, this speaks a lot to like how organizations might deal with failures, where it's like, oh yeah, that was implemented by the PM's team who he left 2 cycles ago. Why does it work this way, kind of thing, right? And there was probably good reasons, but it's been lost in the ether. Yeah.
Right. Or it's in the spec. We just implement the spec. What are you going to do? Right. Yeah. I mean, yeah, authorization is obviously a big key, I think, in the move away. I mean, obviously, I was saying like access lists are a centralized version. It's kind of the anti-decentralized way. It's something that we've obviously been thinking a lot about in Fission in our work there, the few cans and everything to move away from that model. But yeah, I mean, it is kind of a key layer, right? I mean, I think you know. But let alone, you know, the worry that I say worry that I have, and that's everything that we do, let's say Fission with identity storage and compute is, you know, if everybody can participate, which is great, to this whole point of like this paper, how do you make sure, how do you restrict people? You know, you want to give them the power to do certain things, but you want to restrict them enough where you can get good data, you can get good information, you can actually create a story for what's happening when things do go wrong. You know, we talk a lot, like the stuff I work on with IPVM, it's like we want to have this ability for anybody to do different kinds of compute and participate in a series of steps of computation. And it's like, cool, you know, and it always kind of begins with like, okay, we'll work with this trusted service who works over like IPFS or something else decentralized like that as the kind of infrastructure. Cool, but they're trusted. But now you're like, oh, I want to have anybody come in and be like, cool, I can run this. I have this cool, you know, LLM, or, you know, I mean, I think of it even like with Blue Sky, right? Custom feed generator. And it's really, really great. And you should let me participate and compute your data to give you custom feeds, et cetera, whatever. Except that, you know, when they run it, their custom feeds do either terrible, like they show terrible imagery, or, you know, you don't know, right? Like you're kind of now allowing for those participation. Of course, you're like, hopefully it can just be moderated, but moderating it, you know, gets you back into, well, then who has access, who has control. Obviously, I think like things that we do with UCANs and stuff go a long way toward this, and stuff that Blaine's working on with NNS. But then you have to make sure everybody agrees, or everybody who will participate, there's still like a restriction. Like you have to participate with this technology, with these ideas, or with this system. It's not a complete free for all, right? All right. So yeah, anything else, I guess to go back on the paper a bit. I mean, I think the big chunk that left out in this paper is like how to take all this information for use for good endeavors, or, you know, what is the story after this, right? And I think that's in the other the reading group, right? They mention kind of this as one of the things that's kind of left at the table, right? Not the best conclusive work of where things have gone, right? They kind of just talk about, hey, we can do this kind of multidimensional cross correlation, and then that's pretty much it. I don't know if anyone, you know, in a paper like this, and we've kind of done 2 taxonomy papers now. The last one was about schedulers. You know, it's funny because I think in a previous reading group, we had someone who's like, where's something where I can get all the terms and the whole understanding? And sometimes the problem with these taxonomy papers, you get a lot of terms, you get a lot of understanding, but there's a lack of like vision maybe. And so, you know, maybe this is the the double-edged sword of trying to categorize everything. But anyone else with anything before we wrap up for today? Yeah, cool. All right. We'll have. I don't have any sessions up yet, but we will. I'll schedule the next 3. So probably some point in mid-August, but I'll schedule that this week. So look for some papers. Brian?
I don't have one specifically, but do folks have requests of things that they'd like to read or
yeah,
sort of
please.
area,
That was
topic areas?
exactly what I was going to say. So,
Cool.
Sharon, maybe?
No, I have one clarification. So, Blaine, can you explain what do you mean by the organization role in this kind of bugs is not explained in the paper? What do you mean by that? I was not able to follow.
Oh, you know what I was saying? I was saying that while the kind of conclusive parts of this work doesn't talk about like how to use this data to further mitigate possible problems down the line as much, is what I was trying to get at there. Please.
My request, and again, this is maybe like, asking for the moon, but I'm really kind of stymied by the whole problem of accounting and like tracking or somehow tracking utilization or usage or consumption of a resource. And I just wonder if that's like a thing. Like, are there folks who are like doing like, like really sophisticated? Like, has anybody figured that out? Sure.
Just to be sure, talk more about what you mean by resource.
Yeah, like for example, let's say that there's something. Well, let's say that let's say again, going back to the Mastodon example, you've got something like pixel fed, right? Distributed image sharing or videos. Something that might like, is it possible for a particular server or the owner of an asset to just like mark something as, oh, I want to almost like get like a beacon or something. I want to somehow keep track of how many views, how many times this is viewed, or how many times it's copied or played, right? So, is there like a way of like, has somebody come up with like a record keeping or a cookie format, or God knows, I don't know. But something that would allow like counters to be exchanged. Like, well, I guess the first thing is, can somebody choose an asset and say, oh, I want to track the consumption of X, whatever it is. And then the second thing would be, having made that decision, is there a method to implement that wish or that desire? Does that make sense? Basically what I'm getting at is, I'm looking into the possibility of forming like infrastructure co-ops, like people who might want to host infrastructure. Because I have an intuition that more and more companies are going to want to not use Amazon or not run their business on, Amazon or Google. And so maybe if they were like employee-owned co-ops, businesses that you can expect to be around for multiple generations because it's in the interest of the stakeholders to not sell out. How can one track, the consumption of resources might need to be tracked differently than there.
Yeah, I would say like generally there's actually a lot of great work on the tracking of provenance, how to share provenance. I think that's the word I get of when I think of what you're talking about. Like,
okay,
the provenance is essentially like, from the root to as it grows, and then counters in particular are one where like there are ways of we tell about CRPs and stuff, ways share counters. But of course, like provenance, I think there's a lot of interesting research generally around provenance. There's a lot of stuff like memory tracking. All this kind of different fields. The thing that where you're coming from, which is interesting, is obviously more akin to like, when you mentioned the counting, right, which might, a domain that might
Billing.
not,
Yeah.
might not be treated in the same way that we treat provenance for things like bug tracking over time and historical understanding, which comes more from technical perspectives, but less from like the accounting perspectives that maybe that you're trying to talk about. So that's and obviously when we think about research in general, it's like, I mean, and a lot of papers are, depending on the field, it's always about what is the thing you're doing and what domain are you applying it to, right? And sometimes, it's like, oh, I can take this cool, deep learning trick and apply it to programming languages, or I take, and that's where like domains and then algorithms, data structures, technical feats kind of come together in interesting ways. So I think there's something you're kind of maybe bridging there, at least.
Yeah, exactly. Like, is
getting
there somebody who's like come up with like a derivative or a construct? There are people who sit around coming up with like puts and calls and straddles and stuff like that. Is there a way of like coming up with some something that would represent some unit of consumption of resource? I don't know what that would look like. I mean,
obviously, in like, we do a lot of WASM, and WASM does have like this concept of like fuel, which is used as consumption there. For example, and it's built into like the semantics for WASM generally, and runtimes do implement it. So, and then you can, go for it, Brian.
I was just going to mention, I don't know if it was recorded, but at DWeb Camp just a couple weeks ago, there was a talk on data provenance, and the Filecoin Green project is working on doing carbon offsets in a way that like they had a whole sort of demo set up where you could like go and attest that you had attended the conference and how far you had driven. And they would establish like a carbon offset for your trip, and that they talked a little bit more generally about data provenance and like where do we put trust and how do we trust that, and so if you can find that talk, that would be great. Or maybe Filecoin Green has a write up about like what they're doing.
Yeah, we should. We use Discord and try to come up with something there to put on the list for this year. I think that would be good. Maybe there's something. I mean, there's a lot of data provenance stuff, right? To your point, Brian, too. But like, there's obviously it's such a big field, actually, right? Tracking provenance is such a major thing. So, but cool. Awesome.